Um, could you help us understand what viruses are related to the microbiome as a whole?
Well, even in the paper that I mentioned, so I mentioned right here the kind of the Hendrix product, which is the product of measuring double-stranded viruses in kind of our Earth ecospheres, right, our ecosystems, right? Um, if you look at the human body and just generally the abundances, and I said that we're kind of our own ecosystem. So how many viruses do you have in your mouth, and how many viruses do you have in your gut, right? And so I give some kind of back of the envelope calculations that the stool virome has around 10 to the 11 viral-like particles. Saliva has around 10 to the 11. That's equivalent to the number of stars in the Milky Way galaxy, right? Just the double-stranded DNA viruses that we can measure, right? And so we have this tremendous abundance, both of viruses that are not viruses that infect you and me. There are some, right? But most of them infect bacteria. And those bacteria then are lysed and evolve as a product of those viruses. And if you have more or less viral diversity as you age, it appears like when you have much more viral diversity when you're younger, and then it kind of settles down and you have less viral diversity. But maybe that viral diversity is incredibly important. Maybe fecal transplant isn't necessarily the microbes that are providing the genes that are providing the health benefits. Maybe it's the viruses. And so they did this study where they, filtered out the microbes and they put the viruses in, and they got the same effect, right? And so I think the future, as I mentioned, the future of virology is synthetic. So the idea of being able to tailor microbiomes and viromes, or I think of the microbiome as not just bacteria. Most people just think bacteria, but I think of them as viruses and fungi and these other things. But to then tailor them to precision nutrition and precision needs that you need. And that we know that the microbiome in its entirety is a training wheels for the immune system, right? And so we might be able to help with all these other autoimmune diseases and these things that we're seeing now by having tailored microbiomes of people. Eventually, you might be able to have a thing on your bench top that measures you every morning and says, oh, well, you're low on bifido or you're low on this. And so let's, oh, you need to go to the thing and get a new transplant, and then you're getting that transplant and then you're feeling better that day. Right. And that I also kind of have this thing that we work on in my lab is this thing of the kind of the microbial shield, this shield of microbes that are part of you and part of the environment as well that protect you from disease. And it's really the breakpoints within the shield that people get sick, and understanding those breakpoints, and whether the phage are involved or even viruses. I worked on my master's degree. I worked on a virus called human peggyvirus G that makes you live longer when you're HIV positive. You're less likely to progress to AIDS when you have the presence of this virus. And so, there's a lot of good boy viruses out there. I know we're dealing with a global pandemic, but they're more friend than foe. And the reason we exist at all